Hello math students, it's Mr. Ray. We're going to start off the course with a little review, but before we get to some of the types of things we did in grade 9, I'd like to just make sure everybody understands the terminology. There's a lot of terms that we use in math and they can be easily confused with each other. So hopefully I'm going to do a comparison here. It's not a stretch at all. Math is a language, just like English, French, Spanish, any other language, and it has its own syntax and the way it's put together to be able to communicate. Okay, and out of this comparison, we're going to come up with the math terms that we use. Okay, so all languages will start with an alphabet, the symbols we use, and those symbols are then combined together to create words, and then the words are combined together to create sentences. So, and you can, I don't have to explain how that works in your language, but in math, and actually math is the language of science. I've always believed that the way science laws are communicated and science acts is all based on mathematics, and so you'll hear that quite often, that math is the language of science. Okay, but in terms of the way it's constructed, okay, the alphabet for math, you should be able to say, well, we use numbers for math, right? So that's definitely part of the math alphabet, not the whole alphabet for math. And these are things like integers, positive integers, negative integers. We've got fractions, negative as well. We've got decimals. Okay. Now, these are what we call these in math, the numbers, those are called constants. So there's our first math term. And the word constant means the same thing in math as it does in English. It means something that doesn't change. So these values never change, okay? So that's basically why they're called constants. Now we have other parts of the alphabet that that do change. So we call those variables, okay? And when we have a variable in math, it's because either we don't know what the number is, or maybe it's something that we want to be able to change what the number is and to try things out. So by far the most common variables in math are x and y. We use those a whole lot, but it's not just limited to those letters. It can be any letters. It can be A, B, C. It can be capital letters as well as small. It could be now. I'm not going to list all the letters. We usually try to italicize the variables when we use them in math, just so they don't get mixed up with the math symbols like multiply and stuff like that. So there's, those are the letters part of the variables, but we also, it's not confined to the English letters. We also use Greek alphabet letters. Like this symbol here is called theta, and you're going to see that later in the course. Theta is kind of a variable that's used to represent an unknown angle, okay? But it can be any letter from any alphabet. It could be a box, square box. It could be, a question mark sometimes. So, like I've written here already, we call those variables. So the alphabet in math is composed of constants, which don't change, and variables which do change, and represented through the number systems and through the alphabet letters, amongst other things. Okay, now what we do with our constants and variables, we actually combine these to create the equivalent of words. So what we do is we stick these together by multiplying. So we combine by multiplying numbers and variables. So for example, I could take I could take the number 2 and the variable x, multiply them together, and we get something like 2x. In math, if there's, if they're up against each other like that, that means we're multiplying together. So 2 times x, that's basically a math word. Okay, and we could also just have the variable itself, or we could have a number itself. Those are still words. Okay, we could have something with a fraction and a letter. We could have a decimal and a letter. So these are all examples of math words. And we could combine, if we had 2 numbers, if we multiply them, it just create another number, right? So we only really see one number. I'm including fractions as one number. But we could also have more than one variable. For example, -3ab. So that's -3 times a times b. That's a math word. Okay. And you can also multiply that same variable by itself. For example, x times x is x squared, so I could multiply, say, a 3x squared. So that's 3 times x. And you could really develop a lot. So 2.4x squared, so that's multiplying 2 x's together. Y cubed, that's multiplying 3 y's together, and z. So these are all words because it's just multiplying combinations of constants and variables together. Now, what do we call these things in math? We call these terms. Okay, so far we've got constants, variables, and when we multiply those together, we get terms. And here's lots of examples of terms. Okay, now once we got a collection of these terms, you can see there's infinite number of terms, there's an infinite number of constants and variables, so there's infinite number of sentences that you can create with these terms. So what we do now is we add these, we combine the terms together by adding or subtracting. So combine by adding or subtracting terms together. So I could have, if I just took some of these, I could have like x and -3. I could have 8.2b minus 3x squared. Okay. You could also have one-word sentences, like hey. So I could, 2/3 y. Not only is that a word or a term, it could also be one of these math sentences, which we'll get to the word in a second. What does that mean? 2/3 y. Now, I could have something like, x cubed plus 2x squared or minus x plus 3. So that's combining actually 4 terms together to create a sentence. Now, what do we call these math sentences? We call these, well, there's a couple of different terms for this, or words for this. This is expressions. We also call them polynomials. So we actually use both of these. Okay, polynomials is a little bit more restrictive. Don't really need to know that for grade 10, but in terms of what we're doing this year, it's basically the same thing. So how do we, if I gave you an expression or a polynomial like this guy here, how would you know how many terms there are? Well, the easiest way to explain that is that the terms are separated by a plus or minus sign. So you could take this, everywhere you see a plus or minus sign, you can kind of break it apart and then count 1, 2, 3, 4. This would be 4 terms. So this would be called a 4-term expression or a 4-term polynomial. Okay. Now, So that basically explains the language part. So now we kind of go outside that comparison. But I could actually take two sentences, or in this case, expressions. I could have something like expression 1. So I'm just identifying that as an expression is equal to expression 2. Okay, now the big change here is we've taken two different expressions and we've got an equal sign in between. You notice everywhere before here we never talked about equals. We had plus and minus, we had multiplying to create the words, the terms, a little division here with the 2 and the 3, but that just created a different number. But we never had an equal sign before. So anytime we have something like this where you have one expression equal to another expression with an equal sign somewhere in between them, we call this, and you always remember what we call it because the equal sign starts with EQ, U, A. So you can kind of guess this would be an equation. Okay, so there's another term. Okay, now a term in math. Now an equation is very specific. Okay, a lot of students will get mixed up. So here's an example of an expression. I might say 2x plus 4 is equal to 10. Okay, that's an expression because it's got an equal sign between two expressions. If I just had equals 2x plus 4, that's not an equation because it doesn't have anything over here. So that's really just an expression, okay? So it's very important that you have something on both sides of the equal sign to call it an equation. And the thing we do with equations, we solve equations. So in this case, you would solve by saying solve, it means figure out the mystery, okay? Solve the mystery. The mystery is, what is that unknown thing? So if we're going to solve this, you did this in grade 9, and I'll just do this really quickly. You would subtract 4 from both sides. You're trying to keep both sides, do the same thing to both sides, so we subtract 4, and then we know 2x is equal to 6, so if I want just what's 1x, we divide both sides by 2, and we get x is equal to 3. So that's how we solve an equation. I'm not going to go into detail of that. Sorry about that. I guess you weren't seeing what I was writing. Okay, so there's the 2x plus 4. That's an equation. When we solve it, we basically want to isolate x by itself. So we do things to both sides so that we get x by itself. We subtract 6, divide by 2, and we get the value of x. And if you plug that back in here, 2 times 3 is 6. 6 plus 4 is equal to 10. So this is true. So we know that that is the correct value for x. Okay. Now one other thing, and that's translating. Okay. So a lot of times in math, we'll have problems that are just math or, terms and numbers and, equal sign problems where we have to figure out, we have to do something with it. And other times, the problem's given us to in words. And it's the notorious word problem that students are terrorized by in school. And I want you to get a better feeling for word problems, hopefully. So let's take a look at translating. So if I want to translate from English to math, because we just said that math is a language. Okay, so I'll do a fairly straightforward one. But before, actually, I'll write the problem first, and then I'll talk about how we do it. Okay, so this word problem says 3 less than triple Sunny's age is 42. How old is Sunny? Oops, how old is Sunny? Okay, so that's a pretty standard looking word problem. Okay, now before we translate, we need to know, what do some of these words mean in math, okay? So let's talk about some of the pretty standard math symbols. We got, the plus sign, we've got minus sign, multiply, divide, we've got equals to. So we'll stick with those for now. Okay, so what are these symbols, how could we describe in a couple of ways how these would be mentioned in a word problem? Okay, so plus is, if you saw the word add, definitely you'd know that. So add, the word sum means when you add two numbers together, or if you could use the word combined. If two numbers are combined, you're adding them. So these are English words which kind of relate to the plus sign. The subtraction sign, you could see, well, obviously subtract, I won't put that, but difference, the difference between two numbers means you're subtracting them. Or if you said less than, that means you're subtracting something. Okay, multiply, it could be a few different things. Like if you said double, something's doubled another number, it means you're multiplying by 2, or triple. There's lots of other ones there, but those are pretty standard. The division symbol, it might be, half of something, or a quarter of something. It means you're dividing by 2 or dividing by 4, etc. And the equal sign, very important. If you see, the word is, that's the big one, or equal to, obviously. Okay, so there's our kind of translation guide for this question. So when I look at this question, and this is how I'd recommend you do it, the first thing I'm going to do is look for the numbers and the variables. Okay, so the numbers should be straightforward. Sometimes they're actually written as numbers. So I'm going to put, the number 3 here. Less than triple. So triple means 3. And we know that that relates to multiplying. We'll get to that in a second. 42, that's not too hard to translate. Now, so we got 3 numbers. What about variables? So variable is the thing that you don't know. Okay, and the thing that we don't know, the easiest way to find that is, what is the question asking for? The question's asking for how old is Sunny, or Sunny's age. Okay, so Sunny's age is right here. So that's the unknown, or the variable. So let's be really boring, and we'll just call this X. Okay, so we're letting Sunny's age be represented by X. Okay, so we've got the numbers, we've got the variables, and now we have to do our translation here. So what we see here, well, remember the word triple means multiply. So it's multiplying Sunny's age, so that basically becomes 3x. Okay, so we've got a 3x here. I'll start making my translation result down here. You don't have to do this stuff, obviously, but sometimes it makes it easier to start off that way. So I've got triple Sunny's age is 3x, and 3 less than this. Okay, so less than means you're subtracting. So when you subtract, you have to be very careful the order you do it. Okay, because unlike adding, it does matter the order. So you have to ask yourself, should it be 3 minus 3x, or 3x minus 3? And it always goes, you just try it out and then you can get it pretty quick. 3 less than this. So it means we're taking this and we're subtracting 3. Okay, so that's where that 3 comes from. That 3x is there. And so we've done everything up to here, and then that magical word is means equals to, and then the number 42. Okay. All right, so we've actually modeled, and that's another math word, modeled. We've modeled this this English word problem into a math word problem. Okay. And we're letting X represent Sunny's age, and now what we want to do is solve it, and this, I'll do the same thing that we kind of did before. We want to do same thing to both sides and get X by itself in the end. Okay, so the first thing we're going to do is get rid of, we don't want that there, so we're going to add 3 to both sides. When we add 3 to this side, it cancels out that subtraction. When we add 3 to this side, we get 45. And now, just like before, we know what 3x is, we only want 1, so we divide by the number that's out in front, the coefficient. Okay, and that means we get x equals 15, so therefore Sunny is 15 years old. Okay, so hopefully this little mini lesson reminds you of some of the math terminology. It can get confusing if you haven't taken math in a while and you start seeing questions that talk about terms and expressions and equations and variables, okay, and modeling word problems. Okay, so hopefully that gets your brain going. Hopefully you remembered it makes sense that you can relate math as just another language. Okay, so that's it for now. We will also do another lesson kind of going through some of the grade 9 stuff that we learned, just to make sure that you're up to speed on that. All right, so there is a little mini 5-question quiz for this based on what I just talked about. I'm not scoring your mark. I do want to look at it to see if you understand it, but you do need to complete the quiz before you can go to the next lesson on the grade 9 review. Okay? All right, have a great day.